Hello, 8th grade. Welcome to your first video lesson. Today, you should be on lesson 4, which is negative and zero exponents. Today's date should be the 26th. Okay, so in the last lesson, we learned how to simplify fractions where we have two equal bases raised to exponents. So let's go ahead and simplify each of the following. So you're going to do this part on your own. And then write the general property in D. So you're going to simplify A, B, and C. And then you're going to generalize it in D. So what do we do to those exponents when we're dividing it? Okay, so if we look at the first one, I want you to remember that when we're dividing exponents, we subtract them. So it would be 8 to the 5 minus 2. Now this is really important. It's 5 minus 2, and it's in the numerator because the greatest number for the exponent is in the numerator. Same with B, and same with C. Okay, so what is 5 minus 2? It's 3. So it is 8 to the third power. All right, our next one is 5 to the 11 minus 4. 11 minus 4 is 7, so it's 5 to the 7th power. This one is x to the 6 minus 2. 6 minus 2 is 4, so it's x to the 4th. Now, how do you think we could generalize this? We would do x to the a minus b. Now, next part's really important, but I've already mentioned it, that it makes a lot of sense when the numerator is greater than the denominator. But what if the exponents are equal, or even worse, what if the numerator is smaller than the denominator? So we're going to go over today those specific rules when exponents are equal and when the denominator exponent is greater than the numerator. So something always important when you're looking at these is that you have to make sure that your bases are the same. So this expression, 2 to the third over 2 to the third, our bases are both 2. So let's go ahead and look at that. 2 to the 3 minus 3, well, that's equal to 0. 2 to the 0 power. But we don't know how to simplify that yet, right? So what if we just simplified the fraction? Let's go ahead and expand it out. 2 times 2 times 2 over 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, over 8, and that's equal to 1. Okay, so anything to the 0 power, when we are going to multiply that out, is always going to equal 1. And that is our exponent property for 0 exponents. So let's look at this next one. How would I simplify 5 to the x to the 0 power? I want you to remember that 5 is not raised to any power, but x is raised to the 0 power. Go ahead and try that one. So 5 to the x to the 0 power is equal to 5 times 1 is equal to 5. All right, let's do a few practice problems. And it says, use your calculator to verify the zero exponent property. So 25 to the 0 power, all of these should be what? They're all raised to the 0 power. They should all be 1. So I'm going to give you a second to verify that these are all 1 by using a calculator. Now, what does your calculator give as an answer to 0 to the 0 power? Go ahead and put that in your calculator. Okay, it should say something like undefined or give you an error. That's indeterminate. That means that does not have a value because we cannot divide 0 by 0. All right. So now we're going to introduce negative exponents. So negative exponents tell us to divide. So let's go ahead and look see how we come up with a negative exponent first. So let's use the exponent law as it's written, which was x a over x to b equals x to the a minus b. Okay, so 2 to the squared over 2 to the fifth should be 2 raised to the power of 2 minus 5, which would be 2 to the negative third. So we don't know what to do with that yet, but you will soon find out. Why don't we go ahead and evaluate that? 2 times 2 over 2 times 2 times 2 times 2 times 2. This time I don't want you to multiply these out. What we're going to do is we're going to find forms of 1 in here. So let's cross out 2 over 2 because that equals 1. And then we have another 1 right here. So now I see something. On the top I have 1 times 1, which is 1. The numerator, not the top. And the bottom I have 1 times 1 times 2 times 2 times 2. And that's 1 over, let's just write it as 2 to the third. So we have a fraction. So it looks like negative exponents. When it says it tells us to divide, we're actually going to be writing these as fractions. So let's write that as 1 over e to the n. So your negative exponents just move that exponent from the numerator to the denominator and then make the exponent positive. Okay? So this is my exponent property. That's my negative exponent property right there. Okay, so what would 2 to the negative 2 equal? So I know that 2 to the negative 2, I'm going to turn it into a fraction with the base as the denominator. And then that exponent just becomes positive. Okay, so let's multiply that out, and then you're going to put it in the calculator and see if you are correct. Okay, so the answer here I got is 1/4, which is equal to, in decimal, which is what you probably got in your calculator, is equal to 25 hundredths. Because it's 1/4, right? 1/4 is 1/4. All right. Okay, so negative and zero exponents are extremely important in math because they can seem exceptionally strange when first encountered. But what I want you to do here is I just want you to rewrite these. So let's do 1 together. 1 over 3 squared is equal to 1 over 3 times 3, which is equal to 1 over 9. Okay. We want to leave these as fractions because we don't want to put these in the calculator. The calculator is going to give us decimals. So here's a little trick, and we'll try it with 5 to the negative 3. So that's 1 over 5 cubed. Just put 5 cubed in your calculator, and then you can write that answer there. So 5 times 5 times 5 should be 125. Okay, so why don't you try to do the rest of these on your own and check back when you're done. Okay, how did you do? Go ahead and check in your answers here. So when you go into your ALEKS practice, you are going to see some problems like this. Exercise 6. Write the expression in simplest form. That means you have to go back and think about your other exponent rules. So when I have a power of a power, I multiply. So the first step is actually to do 2 times negative 3. So 10 to the 2 times negative 3 power. Then you're going to come up with 10 to the negative 6 power. Now you can write it as 1 over 10 to the 6. So when you're dealing with variables, you're going to leave it in this form. Okay? But when you're dealing with whole numbers, or if they're asking you to write it all the way out. So for the most part, you are going to leave your answers in that exponential form. But occasionally, you will have to write it out. So you can put 10 to the 6 in your calculator. That's going to stay in the denominator. Quick and easy trick for tens is the exponents is raised to is how many zeros you're going to have. So that's 1 over 1 million. But again, for the most part, you're going to leave it in exponential form, especially with variables. All right, I'm going to see if there is a variable problem down here I can give you an example of that for. And there is not. Okay, so you have lesson 4 ALEKS. Whoops. Oops. All right, I will get this for ALEKS practice to complete for today. All right, and I'll see you back for another video tomorrow.